Welcome back, everybody. So we are going to get into the second part of our notes, or of our set of problems. So in the first video, we just looked at how to solve a basic equation where you have something like, the sine of x equals, some number like, we call it m, okay? And we should be able to solve x from what we did in the last video. Now in this video, we're going to be looking at two types of equations where we have, instead of x, we have some sort of mess equals m, right? Where mess is going to be some x, something involving an x or another variable. And in this case, we can't maybe solve for x directly, but we can see what the mess is going to be, right? We can see what the mess is going to be something, and then we can solve from there. We can solve for x. That's one type of problem. Second problem is when we have some mess in terms of x, okay, and if that's equal to some constant m, okay, and then what we want to do is we want to get eventually we want to get something like the sine of x equals some mess, so maybe some different number over here, which will be n, okay. So that's the idea, what we want to do. So if we look at these, look at some of these, see what we want to do. The main thing we want to get it down so we have sine or some trig function of something equals something. That's the strategy in all cases. So in this case, we can 2 sine x equals 1. I think if we can isolate the sine x, we're basically done, and we can do that if we divide both sides by 2, and we'll get the sine of x equals 1/2. Okay. And then from there, we know that the solution is going to be x equals pi over 6 plus 2 pi k. And then there will also be another solution. It will be the 5 pi over 6, or actually, I'm sorry, minus pi over 6 plus 2 pi k. Right. I'm sorry, I was right the first time. 5 pi over 6. Plus 2 pi k. Okay, where again k is going to be any integer, 0, plus or minus 1, plus or minus 2, and so on. Okay, so that's that. Then the cosine. Now in this case, this is a different situation where the 2x is on the 2 is on the inside. So if we wanted to, we could basically find what 2x is first. 2x is an angle whose cosine is 1. Well, that means that 2x has to be equal to 0 or some multiple of 2 pi, right? All right. Because basically, what we're doing is we can make a substitution if we want. We can call this y, and so the cosine of y is 1. So y is going to be equal to 0 plus 2 pi k. If we don't want to do this, we could bring a y in here. We can just call this 2x. Okay, we don't necessarily have to bring in a new variable. But now we would just solve for x. We can divide everything by 2. And so x now is going to be, 0 divided by 2 is still 0. And then this is pi k. Okay. So for solutions like this, we'll have solutions like 0, pi, 2 pi, and so on. Okay. Also we get negative pi, negative 2 pi, and so on. Okay. So those would be all the solutions there. Let's say if we had the tangent of 5x. Same thing. We have tangent of some mess. Actually, this mess isn't very large of a mess. We can call this just 5x, so we can call this y if we want. What tangent has, we recall the tangent, an angle whose tangent is negative 1, that's negative pi over 4. So we could let y be negative pi over 4 plus pi k, because again the period of tangent is pi. So this would mean that 5x is negative pi over 4 plus pi k. And now we can divide everything by 5. And if we get that, we get x is going to be negative pi over 20 plus pi k over 5. Okay, where again k is an integer. So we can describe solutions like this. And now if we wanted to get a few solutions here, obviously we get, if k is 1, we get minus pi over 20. If k is, that's if k is 0. If k is 1, that's pi over 5 is the same thing as 4 pi over 20. So this would be, in fact, we can actually rewrite this as negative pi plus 4 pi k over 20. So if k equals 0, we get this. If k equals 1, we get 3 pi over 20. When k equals 2, we get 7 pi over 20. When k equals 3, we get 11 pi over 20. And so on. We can get as many solutions as we want this way. All right. Okay, did I make sure that I, hopefully I didn't make a mistake here. K equals 3, let's see, yep, looks like my mistake was in my notes, so everything's cool. Yeah. All right, let's look at number 4. We have the 4 times the cosine squared of x equals 3. In this case, we can, well, our first natural impulse is to divide by 4. So we get cosine squared of x equals 3/4. That's great. Now, then we could take the square root and find what cosine is. Remember, there's no, we have no idea what quadrant any angle is in, so we want to take all possibilities. So cosine of x could be negative, or it could be positive. So we can see the cosine of x is either going to be the positive square root of 3/4, or cosine of x could be the negative square root of 3/4. And this, of course, reduces to square root 3 over 2. And this would be negative square root 3 over 2. In this case, we would get cosine is the cosine. Well, we have pi over 6 as a solution. But also, on the unit circle, we get that negative pi over 6 as a solution. Okay, so we add 2 pi k to both sides, to everything, to include all the possibilities. And then over here, what angle has cosine equal to negative square root 3 over 2? Well, that's going to be 5 pi over 6, okay, if I in radians. So x could be 5 pi over 6, or it could be 7 pi over 6. And if you're not sure how to get these, just draw the unit circle. Okay, and here's negative square root 3 over 2. So we have an angle here in the second quadrant and an angle here in the third quadrant. Okay, so from here to here is 5 pi over 6. From here to here is negative 5 pi over 6, which is the same, equivalent to 7 pi over 6. And then we have 2 plus 2 pi k. Okay, so here we actually have 4 sets of solutions. Okay, and so you could generate as many numbers as you want here, plugging in a k equals 0, k equals 1, and so on. On number 5, I changed this when it was 3x plus pi on your sheet. That was too easy. I thought it was a little too easy just because pi is the period of the tangent function, so we could just replace that with tangent of 3x plus pi is the same as tangent of 3x. So I'm going to put a pi over 2 here, and let's see what happens. And so what we have is, let's call this angle y again. We want what does y have to be? Well, we know the tangent of 0 is 0. Okay, so we know that 3x plus pi over 2 is going to be 0 plus pi k. Okay, where k is an integer. Now let's subtract pi over 2 from both sides. Okay. And then divide by 3. So this will be pi over 6 plus pi k over 3. Okay. And so now we can again generate as many solutions as we want. We could get negative pi over 6, or we could get positive pi over 6, because that's negative pi over 6 plus pi over 3. That's the same thing as 2 pi over 6. In fact, we could write this as negative pi plus 2 pi k all over 6, right? So when k equals 1, this is pi over 6. When k equals 2, this is 3 pi over 6, which of course is the same thing as pi over 2. When k equals 3, this would be 5 pi over 6, and so on. I think you can see the pattern here. Okay. So you can generate solutions that way. All right. So let's move on, since we're on a roll here. Number 6, we have, this is another case where if we can isolate the tangent of x, we'll be all set. So this is the so we can say square root 3 tangent of x equals negative 1 if we subtract negative 1 from both sides. And then the tangent of x will be negative 1 over square root 3. And this, if you remember what angle has tangent equal to negative 1 over square root 3, it's negative pi over 6. So it's negative pi over 6 plus pi k. Okay. We can bring other trig functions in here too. For the secant, if we can first find what the secant is, and then find what the cosine x is, and then find what x is. So we can isolate this secant by adding 7 to both sides and dividing by 2. Okay, and then take the reciprocal of both sides. We get the reciprocal of secant is cosine of x, and the reciprocal of 7/2 is 2/7. Okay, 2/7 is not one of the well-known cosine values from our unit circle, so we need our calculator. And so x is going to be the inverse cosine of 2/7 plus 2 pi k, or it could be negative inverse cosine of 2/7 plus 2 pi k. And I believe I did this on the ahead of time and on my calculator, and this is 1.281, and this of course will be the opposite of that. Okay, and make sure your calculator is in radians mode. Look at number 8. The cosecant of 3x over 2. Okay, we have cosecant of some mess equals a number. Let's first deal with the cosecant. That's the reciprocal of the sine. So this means the sine of 3x over 2 equals negative 1/2 by taking the reciprocal of both sides. And then notice we don't take the reciprocal of what's in here, okay, because we want to think of this whole thing as one unit. So we have 1 over a cosecant is 1 over is just the sine. And now we can go ahead and solve this. Okay, what angle has sine equal to negative 1/2? Well, that's going to be negative pi over 6. Okay, so that's one of the solutions. So we get 3x over 2 equals negative pi over 6 plus 2 pi k. Or the other solution, what's the other solution if you're not sure? Here's negative 1/2. We get a point here and a point here. So we have an angle in the fourth quadrant and also the third quadrant. This is negative pi over 6, and then 7 pi over 6 over here. Because from here to here is pi, from here to here is pi over 6. So 3x. Okay, and then we want to solve for x. We want to get rid of the 3 and the 2, so this is 3/2 times x, so we're going to multiply everything by 2/3. Okay, and then the first equation then becomes x equals, we have negative 2 pi over 18 plus 2 pi k, well, this will be x times 2/3. Okay. And this actually simplifies to negative pi over 9 plus 4 pi k over 3. Unless I made something screwed up, and I did not, right? So I just screwed up on my notes, but not here. And then in the other situation, we'll have x equals 7 pi, well, let's see, 2 times 7, that's, well, it's 2 times 7, that's 14 pi over 18 plus 2 pi k times 2/3. So 14 over 18, that reduces to 7 over 9, so this will be 7 pi over 9 plus 4 pi k over 3. Okay, so I didn't have time. We don't have room to do this, but you can plug in some other values. If you plug in k equals 1, you'll get negative 9 plus 4 pi over 3. You can simplify that. I think that becomes 11 pi over 9. And when you plug in k equals 1 here, this becomes 23 pi over 9, I think. Okay, so you can go ahead and generate as many solutions as you want. Okay. Again, hopefully you remember where this 14 comes. You can see this. This should be 14, and that we got that from 2 times 7, right? Okay, and the 18 is 3 times 6. All right, number 9. Cotangent of x equals 5. 6 times the cotangent of x is 5. We want to find what cotangent x is first, so we can do that by dividing by 6. And we get the cotangent is 5/6. Flip this around, take the reciprocal of both sides, and we get the tangent of x is 6/5. Okay, so then we can see that x is going to be the inverse tangent of 6/5 plus pi k, and this will be, in our calculator, this turns out to be 0.876. And then for problem 10, you can try to do this. You can go ahead and take the reciprocal, and you'll get cosine of, well, we have secant of 2x equals 1/5. Now, if you're really sharp, you'll realize, or if you remember, what's the range of the secant? The secant of anything that has to be either greater than or equal to 1 or less than or equal to -1. Negative, or 1/5 is not in this range, so this should probably have no solution. And if you didn't see that at first, if you try to take the cosine, take the reciprocal, you get the cosine of 2x equals 5. And at this point, this should really send your alarm bells going, because the cosine of anything has to be between 1 and -1. So at this point, we don't even have to deal with this 2x. We know this has no solution. Okay, because 5 is not in the range of the cosine. So let's redo this problem. Let's call this 11a, and let's say we just made this the cosine. Let's say the secant of x, the secant of 2x was 5. Then the cosine of 2x would be 1/5. And this does have a solution. This does make sense, because the cosine could be 1/5. What does this mean? Well, what does it say about 2x? Well, 2x then could be the inverse cosine of 1/5 plus 2 pi k, or it could be, or 2x could be the negative inverse cosine of 1/5 plus 2 pi k. And at this point, we can divide both sides by 2. Okay. So in this case, running out of paper here. In this first set, then this first one becomes x is equal to the inverse cosine of 1/5 over 2 plus pi k, and the second set would be minus this. And so you can use your calculator to figure out what this number is. Okay. In fact, I'll just do this right now. So the inverse cosine of 1/5 is, what is it? It's 1.369, but we want to divide by 2, and so we get 0.684. 685, so x is going to be 0.685 plus pi k, or could be negative 0.685 plus pi k. Okay, so those would be your two sets of solutions. All right, so lots of examples done in this video. Try to figure out, do you have the trig function of a mess equals a number, or so that's one solution, or you could have a mess in terms of a trig function. In either case, you want to reduce it down so you have like the sine of something equals something, or the cosine of something equals something, and then go from there. All right, get some practice, and I'll see you next time.